This is the first of two videos about multiplicative operations, and in this video we're going to look at multiplication. So multiplication and division are concerned with grouping and sharing. In multiplication we have a number of groups which we know, and we know how large the groups are, and multiplication is used to find out the total quantity in those groups. So in this case I have 7 groups. I have 9 flamingos in each group, which means I have 9 multiplied by 7, I have 63 flamingos. Multiplication is commutative. That means that it doesn't matter in which order you multiply the numbers, you'll end up with the same product. So if I have an array like at the bottom here, which is 4 multiplied by 3 equals 12, it doesn't make any difference whether this array is this way up, if it's horizontally, or in any other direction. 4 times 3, 3 times 4, it's going to give you 12. But just because it will give you the same product, it doesn't mean it has the same meaning in context. So if we have 3 bags of 4 chilies, then our multiplication is 4 times 3. We've got 12 chilies altogether. So one of the numbers represents a group size, in this case the 4, and the other number represents the number of groups, in this case it's the 3. Here I've got 4 bags of 3 chilies. So now the 3 is representing the group size and the 4 is representing the number of groups. I've still got 12 chilies. So although it'll have the same product, it doesn't mean it has the same meaning in context. There are 2 arithmetic laws which help us make multiplication calculations simpler. So the associative law says it doesn't matter how we group or rearrange the numbers to multiply them, we're going to end up with the same. So this is often written as A times B, put in brackets, then multiplied by C, will give you the same answer as if you multiply B and C together and then multiply it by A. And we can make use of this to order calculations in a way that makes more sense or is easiest for us to accomplish. So if I have 8 times 2 times 7, this would give me a calculation of 16 times 7, which is not particularly easy to do in your head. But if I rearrange those numbers, so I have 8 times 7 times 2, then 8 times 7 is 56, and 56 multiplied by 2 is a simple calculation, just using doubling. The second law is the distributive law, and this says that we can spread the multiplication out across addition or subtraction to make it easier. This is often called as a split strategy when we spread it across addition, and it's usually called compensation if we spread it across subtraction. So this is how it works. If I've got 58 multiplied by 7, I can split that into 50 multiplied by 7, which is 350, 8 multiplied by 7, which is 56, very badly written 0, and then I can add these 2 figures together to give me an answer of 406. If I'm moving across subtraction, or using compensation as it's sometimes referred to, I've got 37 multiplied by 9, and I can change this into 37 multiplied by 10, and then I can take away 37 multiplied by 1. So I'm making use of the fact that 9 is the same as 10 subtract 1. And I will end up with 370 minus 37, which leaves me with 333. So in formal methods, there are 2 ways of doing things: short multiplication and long multiplication. The only difference in the names is really the number of lines that are involved in writing it out. So short multiplication basically only happens with single-digit multipliers, or if you're multiplying by a multiple of 10, which I will show you in a minute. So let's say we have 87 multiplied by 6. So what happens in short multiplication, if it's laid out like this, 87 multiplied by 6? We're going to do 2 calculations. We're going to do 80 times 6 and 7 times 6. We're actually going to do those the other way round. So I'm going to start off with 7 times 6, which is 42, and 80 times 6, which is 480. And if I add those two together, I will get the answer of 522. Now, your teacher may have shown you how to do the multiplication like this at first to get you used to the idea, but actually this is more complicated than it needs to be, because short multiplication means we don't need to know about the place value. So 87 multiplied by 6. We're going to let the layout do all the place value work for us. 7 times 6 is 42, so that puts 2 into the ones column and a 4 goes into the tens. Then I've got 8 times 6. Now it's really 80 times 6, but I can look at it as 8 times 6 because I'm already in the tens column. So 8 times 6 is 48. I've already got 4 tens in here, so now I've got 52 tens. So the 2 goes into the tens column and I carry the 5. Because there is nothing else to calculate, I can just move the 5 up into the hundreds column here, and my calculation is complete. The reason I could use this if I was multiplying by a multiple of 10, if I had 87 multiplied by 60, I know I'm going to have 0 in the ones, and I can then just continue as I did before. 7 times 6 will give me 42. 8 times 6 is 48. Add the 4 is 52. And again, the place value has been done for me by the layout. Long multiplication is called long multiplication purely because it's got more lines in it. So it's longer on the page. So if we take a calculation like 58 multiplied by 26, the algorithm is going to split that down into 4 separate calculations for us. We're going to multiply 50 by 6 and 8 by 6. Then on the next line we're going to multiply 50 by 20 and 8 by 20. And you may have learnt methods like a grid method or a partial product method where you write the answer to all those calculations down and add them up. But long multiplication makes the entire calculation much simpler because just like with short multiplication, it does all the place value hard work for us. So we always start with the ones, and the first calculation we're going to do is the 58 multiplied by 6. So 8 multiplied by 6 is 48. And then 5 multiplied by 6, which is of course 5 tens multiplied by 6, is 30. Add the 4 tens I've got there, and I've got 34. So 348. Then in the second line, we are going to do the 58 multiplied by 20. So if I've got 8 times 2 tens, I'm starting in the tens column. So 8 times 2 tens, I've got 6 here and I carry the 1. In the UK, we usually put in the 0 here as a placeholder. In other European countries, that's often left blank. Then we've got 5 multiplied by 2. So we've got tens multiplied by tens, which means we're going to end up in the hundreds. So 5 times 2 is 10, 10 hundreds. I've already got 100, which leaves me with 11 hundreds. And then I add those both together, and I've got 8, 10, that one's been carried, 5 and 1, and I end up with the solution 1508. Long multiplication is efficient because it allows you to use only number facts up to 9 multiplied by 9, and as long as you can keep the numbers in the right columns, so particularly if you're using square paper, it should be nice and easy, the place value will do its work for you.